course, Untrusted SSL Certificate. Reception of an Untrusted SSL Certificate error message can be for several reasons. In figure 19.5, the possible reasons for the warning message are shown. The first reason, the security certificate presented by the website was not issued by a trusted certificate authority, means the CA that issued the certificate is not trusted by the local machine. This will occur if the certificate of the CA that issued the certificate is not found in the trusted root certification authorities folder on the local machine. The second reason might occur is that the certificate is not valid. It may be that the certificate was presented before the validity period begins, or it may have expired, meaning the validity period is over. The third reason is the name of the certificate does not match the name listed on the certificate. Incorrect time and device can be the cause of several issues. First, in a Windows environment using Active Directory, a clock skew of more than 5 minutes between a client and a server will prevent communication between the two. Second, when certificates are in use, proper time synchronization is critical for successful operation. Finally, when system logs are sent to a central server such as a syslog server, proper time synchronization is critical to understand the order of events. Exhausted DHCP scope. When a DHCP server is implemented, it is configured with a limited number of IP addresses. When the IP address in a scope are exhausted, any new DHCP clients will be unable to obtain an IP address and will be unable to function on the network. DHCP servers can be set up to provide backup to another DHCP server for the scope. When this is done, it's important to ensure that while the two DHCP servers service the same scope, they do not have any duplicate IP addresses. Blocked TCP UDP ports. When the ports used by common services and applications are blocked either on the network firewall or other personal firewall of a device, it will be impossible to make use of the service or application. One easy way to verify open ports on a device is to execute the netstat command. An example of the output is shown in figure 19.6. Incorrect host-based firewall settings. As you saw in the explanation of blocked TCP UDP ports, incorrect host-based firewall settings can either prevent transmissions or allow unwanted communications. Neither of these outcomes is desirable. One of the best ways to ensure that firewall settings are consistent and correct all the time is to control these settings within a group policy. When you do this, the settings will be checked and reset every policy refresh interval. Incorrect ACL settings. Access control lists are used to control which traffic types can enter and exit ports on the router. When mistakes are made either in the construction of the ACLs or in the application, many devices may be affected. The creation and application of these tools should only be done by those who have been trained in their syntax and in the logic ACL's use in their operation. Unresponsive service. Services can fail for several reasons. Many services depend on other services for their operation. Therefore, the failure of one service sometimes causes a domino effect, taking down other services that depend on it. You can use the services applet in control panel to identify these dependencies as well as start and stop services. To identify the services upon which a particular service depends, use the Dependencies tab on the Services applet as shown in figure 19.7. In figure 19.7, the spooler service is selected and the Dependencies tab is displayed. Here we see that the spooler service depends on the HTTP and the RPC services. Therefore, if the spooler service will not start, we may need to restart one of these two services first. Consider multiple approaches. There are two standard approaches that you can use to establish a theory of probable cause: top to bottom, bottom to top OSI model. As the name implies, when you apply a top-down approach to troubleshooting a networking solution, you start with the user application and work your way down the layers of the OSI model. If a layer is not in good working condition, you inspect the layer below it. When you know that the current layer is not in working condition and you discover that a lower network layer works, you can conclude that the problem is within the layer above the lower working layer. Once you've determined which layer is the lowest layer with the problems, you can begin identifying the cause of the problem from within that layer. The top bottom up approach to troubleshooting a network problem starts with the physical components of the network and work its way up the layers of the OSI model. If you conclude that all the elements associated with a particular layer are in good working order, move on to inspect the elements associated with the next layer up until the causes of the problem are identified. The downside to the bottom-up approach is that it requires you to check every device, interface, and so on. In other words, regardless of the nature of the problem, the bottom-up approach starts with an exhaustive check of all the elements of each layer, starting with the physical layer and working its way up from there. Divide and conquer. Unlike when opting for the top-down and bottom-up troubleshooting strategies, the divide and conquer approach to network troubleshooting doesn't always begin with the investigation at a particular OSI layer. When using the divide and conquer approach, you select a layer, test its health, and based on the results you can move up or down through the model from the layer you begin scrutinizing. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.